Welcome to you in this course Astronomy of Mathematics. What kind of mathematics that will be used in astronomy? Before starting the real concept of astronomy, the mathematics that is being used in astronomy, before that we will master some fundamental concept that will be used in astronomy. We know that there are two kinds of calculus. One is called differential calculus and other is called integral calculus. The basic concepts of differential calculus and integral calculus will be formulated over here in this lecture. So when we talk about the differential calculus, then there are some rules to differentiate. First of all, we should understand that what is differentiation. Differentiation is actually the rate of change in dependent variable with respect to independent variable. So the rate of change in one variable with respect to another variable is called differential calculus. Okay, so differentiation is actually the rate of change in variables with respect to other variables. It's okay. So the first rule which is called power rule, and we should know that in case of differentiations we usually denote just like rate of, if there are two variables, just like if I take one variable x and other variable is y, then the rate of change d means change in y with respect to change in x. Okay, this is actually called the differentiation. Okay, where x and y are two variables. So I am not going a little deeply, I am just explaining the concept that will be used in astronomy. The first rule of differential calculus is power rule. So what is power rule? In this case we take a function, just like I am taking a function y is equal to x raised to the power p. If we take y is equal to x raised to the power p, and what is p? P is any real constant. Here p is any real constant. Okay, if p is any real constant, then if we take the change in y, okay, that is called rate of change in y with respect to rate of change with respect to x. Okay, it will be just like as we will write the power first. Okay, we will write this power p first. Okay, and then after px, and there will be 1 minus from the power p. It will be written as just like as p minus 1. So the language that is used for the power rule is just like as power before, and 1 should be minus from the power. Okay, and this is called power rule. Okay, in power rules we take the power before the term starting. Okay, and then from the variable, since the variable over here is using x, then we will subtract minus 1 from the power. This is called power rule of differentiation. Okay, and let me take some example to understand the power rule. Just like if I will take the example, let y is equal to it is just like x raised to the power 4. Okay, then differentiate with respect to x. We will write it just like as differentiate with respect to x. Means differentiate with respect to x means that we want to find the change in y with respect to x. Okay, so it will be just like as dy by dx, and this will be equal to power as it is, just like as you can see we will write the first power, means we will write first 4 and after that p minus 1, which means that here the power is 4, so 4 minus 1. So this can be written as 4x3. Okay, so this is the power rule. If I take another example to understand about power rules, okay, so I am taking the example over here, just like if we take p, oh yes, okay, uh, remember that what is the derivative of a constant function? Okay, just like y is equal to, if I take y is equal to c, okay, the derivative of the constant function must be 0. dy by dx, it will be equal to 0. Okay, so this is derivative of the constant function is 0. This can be proved by the first principle. The first principle is a method that is used in derivatives, but we are not explaining that. We just want to understand about a little bit differential calculus, the calculus that is being used in astronomy. Okay, not more than this. So let I take another example, just like if we take y is equal to x4 and plus 3x square and plus 9x plus 6. Okay, so if we want to differentiate with respect to x, we will write just like as differentiate with respect to x. When we differentiate with respect to x, then it will be just like as dy by dx, and this will be equal to you can see x4. x4 means that you will write first 4 and x, and here you will write 4 minus 1 according to the p rules. Okay, plus here you can see that 3x square, so 2 will be multiplied with 3 and it will be over here we will write 6, and x, since the power is 2, so you will get minus 1 according to p rules. Okay, plus 9s, and you know that here the power is 1. Okay, here the power is 1, so you will write when 1 is multiplied with 9, it will be 9. 9x 1 minus 1, and as I have already explained that, okay, here we have explained that the derivative of a constant is 0. So 6 is a constant, so its derivative will be 0. Okay, so this will be equal to 4x3 plus 6x, okay, plus 9. Okay, you know this is 1 minus 1 is 0, so x power 0 is 1. Okay, so this is your answer. Okay, so you can see over here that we have used power rules. Okay, so there are some other rules. Okay, move to that rules, just like the second is the product rule. So what is product rule? To understand about the product rule, uh, the product rule is just like as there is a function, and the function is just like as it is f of x. Yes, if the function is f of x, which is equal to u of x, okay, u of x and v of x, u of x and v of x. Okay, so we want to find the derivative, so its rule is also we can write f prime of x. F prime of x means that derivative, first derivative with respect to x. So dy by dx can also be written as y prime. Okay, so here it is. The product rule is you will write first as it, means this is your first function and this is your second function. The first function as it is means u of x as it is. Derivative of the second function, which means derivative of the okay, v prime of x. And in the similar way you will write plus v of x second function as it is, and therefore derivative of the first function means u prime of x. So once again you can see that this is your first function and this is your second function. So first function is first function, okay, and this is your second function. In the second functions you will write just like as, okay, first as it is derivative of the second plus second as it is derivative of the first. So this is the way to find the derivative by the product rule. But remember that when we apply the product rule when there are two functions u of x and v of x, okay. So let me take the example where the product rule, we will apply the product rule just like as the example is for the product rule. It is just like if I will write y is equal to just like it is 2y square is equal to 3xy, okay, and we want to find the dy by dx. What we will do, differentiate with respect to x on both sides, okay, differentiate with respect to x on both side, okay. So on the left hand side you can see there is only one function which is y, but on the right hand side there are two functions, one is x and the second is y. Of course 3 is constant over here. So differentiate with respect to x on both sides, it will be just like as, okay, here you will apply the power rule. For power 2 will be multiplied with 2, so we will write 2 and no, we will write 4 because when 2 will multiply with 2 it will be 4, okay. So 4y, okay, and derivative of y, and the derivative of y is dy by dx and it can be represented by y prime, okay. Once again 2 will be multiplied with 2, it will be 4, okay, and when we subtract 1 from 2 it will be here it is 1, okay, no need to write 1 over here because power is 1. So with respect to, okay, since we are taking the derivative with respect to x, therefore we will take the derivative of y with respect to x. When we take the derivative of y with respect to x, it will be y prime, okay. Actually the language that is used by taking the derivative is just like as power first, subtract 1 from the power and take the derivative without power, okay. So power first, which is 4, subtract 1 from the power and take the derivative without power, and when we take the derivative of y square without power then it will be y prime, okay. So in the similar way 3 and this is x, okay, first as it is, okay, this is your first function and this is your second function, first as it is and derivative of the second which is y prime, okay, plus y as it is and derivative of the first. The derivative of x with respect to x is 1, okay, the derivative of x with respect to x, it will be 1, and it is 4y and y prime which is equal to, multiply inside, it is 3xy prime plus 3y. So 4y and y prime, it will be minus 3xy prime which is equal to 3y, okay. So you can see over here that here y prime is common. If y prime is common then it will be 4y minus 3x and this is equal to 3y, and from here you can write y prime is equal to 3y, okay, and divided by 3y divided by 4y minus 3x. So this is the way how to find the derivative by the product rule. And we will take another example. The second example where the product rule will be used. Okay, so let me take this example just like as I am taking on this side is 5x y square, and on the right side I am taking 6xy plus 7y square plus 8x square and y square. Okay, so we want to find the y prime. Y prime means that the first derivative. Okay, so here you can see there are two functions. The first function is x and the second function is y. Okay, so this is your first function and this is your second function. Let me take the derivative with respect to x. So you will write 5 over here just like as, and x as it is. Remember that first as it is derivative of the second. The derivative of the second means that 2y, and since it is 2y square, y square. Okay, so 2 will be written over here first, and you will subtract 1 from 2, and the power over here will be 1. Okay, and without power the derivative of y square, it is y prime. Okay, and plus y square as it is, and derivative of x, which is 1. Okay, which is equal to 6, and on this side you can see it is x and y. There are two functions. One is x and the second is y. In the similar way that we have to just like as x as it is and derivative of the second, which is y prime, plus y as it is and derivative of the first, which is x. Okay, so first as it is derivative of the second plus second as it derivative of x with respect to x, it is 1. So you will write over here it is 1. Okay, in the similar way plus 7, when you will take the derivative over here, it will be 2 multiplied with 7, then it is 14. Okay, and y square means that the power will be reduced by 1. Okay, so it will be 1 over here, so no need to write 1. And when you will take the derivative without power, it will be y prime. Plus in the similar way it is 8, and here you will see that first as there are two functions, x square and y square. You will take the derivative of x square. Okay, first as it is derivative of the second, y square. The derivative of y square is it is 2y, and without it is y prime. Okay, plus y square as it is, and derivative of x square, it is 2x. Okay, so now multiply inside, which is 5 multiplied by 2, which is 10x y and y prime, and multiply now with 5y square. Okay, is equal to 6xy prime plus 6y. Okay, plus 14y and y prime plus 8x square. Okay, no, it is not 8 only, this is 16. So you will write over here 16. Yes, 16 16 x square y and y prime. In a similar way, plus 16 yes, 16 xy square, 16 xy square. Okay, so now you will take common from just like as you can see the terms which contain y prime. This term contains y prime, this term contains y prime, this term contains y primes, and this term contains y prime. So y prime will be common from these terms. Okay, so here you will get 10 and x y. Okay, here it will be minus 6x. Okay, and it will minus 14y, minus 14y, and you will write over here minus 16 x square y. Okay, and on the right hand side the term without y prime, which is 6y, and the second is plus 16, this one 16xy square, and this term will be 5y square will be minus on this side, 5y square. And now you can write y prime, which is equal to, yes, this term will be divided. Okay, yes, these three terms, the four terms will be divided on other side. So we will write 6y plus 16, yes, 16 xy square, 16 xy square minus 5y square. Okay, and divided by which is 10xy minus 6x minus 14y minus 14y minus 16 x square y. Okay, so this is the way how to apply the product rule. So over here we have applied the product rule. Okay, now the next is quotient rule. Okay, we will understand that what is quotient rule and how to apply the quotient rule. The quotient rule is, we will also use the function just like as it is if, yes, if f of x is equal to u of x divided by v of x, then f prime of x can be written as it is v of x square. Okay, it will be v of x square in the denominator. Okay, and above the denominator means on the numerator v of x as it is and derivative of u of x. Okay, minus u of x as it is and derivative of v of x. Okay, so this is the quotient rule. So you can see it is very simple. Of course, now here there are two functions which are dividing. Okay, the one function is above the denominator, which is called numerator. So this is in the numerator, and in the denominator there are two functions. If there are two functions, then and they are dividing. Okay, the one function is dividing to the other functions, then in this case you will take the derivative just like as this is the formula, which is also called quotient rule. Okay, so to understand the quotient rule, we will take an example. Okay, just like as if I take the example f of x is equal to, it is just like I am taking x over y square. Okay, So since we know that these two functions are dividing each other, okay, are yes, and we want to find the f prime of x. In this case you will find the f prime of x just like as f prime of x, and here it will be, since this is, yes, this is y square, okay, so you will write u of x and y of x, okay, just like as, yes. So if there will be a perfect example, I am looking for a perfect example to apply the quotient rule. Maybe I will find it, okay. So let we apply. It is just like as, or you can say u of x and v of x, actually there should be just like as x plus 1, okay. Here I am writing x plus 1 because the function will be u of x and v of x. So now you can yes, x plus 1 square, it will be x plus 1 square in the denominator, okay, and x plus 1 will be just like as x plus 1, and derivative of x will be 1 minus x, and derivative of x plus 1 will be 1 plus 0. So it will be equal to x plus 1 minus x divided by x plus 1 square, and x is cancelled with my, okay, so this is 1 over x plus 1 square, okay. Now we will understand about another example, just like if I will take it is x plus 2x plus 1 divided by x square plus x square plus 2x plus 1, and this is x square plus 3x plus 4, just like as that. This is the function, and we want to apply the, sorry, this is f of x, and we want to apply the quotient rule. When we apply the quotient rule, f prime of x, and this will be equal to x square plus 3x plus 4, this is square, okay. So x square plus 3x plus 4 as it is, okay, and you will take the derivative of x square plus 2x plus 1, which is 2x plus 2 minus x square plus 2x plus 1, and derivative of x square plus 3x plus 4, it will be 2x plus 3, okay. And now you will just simplify, and how you will simplify, you will multiply x square with 2x, it will be 3, okay, yes, it will be, sorry, not 3, it will be 2x cube, this will be 2x cube plus 2x square. Now multiply 3x with the 2x plus 2, okay, plus 6x plus 6. In the similar way, multiply 4 with 2x plus 2, it will be 8x plus 8, okay, yes, this is just like that, minus multiply x square with 2x plus 3, it will be 2x cube and plus 3x square, okay, and now multiply 2x with 2x plus 3. When you will multiply 2x with 2x plus 3, it will be 4x square. Okay, yes, 4x square, and multiply 2x with 3, it will be 6x plus 6x. Okay, and then multiply 1 with 2x plus 3, it will be 2x plus 3. I think there is a mistake in the over here. Yes, when you multiply 3x with 2x, it will be 6x square. Okay, 3x with 2x, 6x square. Okay, and then when you multiply 3x with 2, it will be 6x, just like s. Okay, yes, and now 8x plus 8, just like s. So 2x cube and minus 2x cube is cancelled, and plus 2x square plus 2x square plus 3, yes, 8x square, and here it is 3x square plus 7x square, so it will be 1x square. Okay, and now it is 6x plus 8x, 14x, and minus 14x minus yes, 14x minus 8x. Okay, it will be 6x. Okay, plus 6x, sorry, 14x, 6x plus 6, or you can say 6x will be cancelled out with 6x, and 8x minus 2x will be 6x. Okay, and now 8 minus 3. Okay, it is 3. 8 minus 3 is 5. So this is the way how to find the derivative for the quotient function. After the quotient function, we are moving a little bit advanced. So now the chain rule. The chain rule is much important in the differentiation. Okay, the chain rule is, it is just like as yes, in the chain rule, if f and g are differential function, if f and g are differential function, okay, then so is the composition of so is the composition of so is the composition FOG, composition of two function. Okay, and derivative of the composition function d by dx, it will be FOG and x which is equal to f prime of g of x. Okay, and here g prime of x. This is the formula. Okay, the derivative of the composition function will be just like as. Okay, FOG is the composition of two functions if f and g are differential function. Remember that the chain rule is applied on the composition of two function, and those functions should be differential. Okay, means we can find the derivative of those functions. Okay, so when we take the composition of those differential function, it will be FOG, and after taking the composition of FOG, we will take the derivative. The derivative will be just like as derivative of the function f, derivative of the function f prime of g of x. Okay, the derivative will be just like as f prime of g of x and g prime of x. So in order to understand more about this, we will take an example how to apply the chain rule. It may be you will not understand about formula, but when you will take the example, you will get understand. Okay, so I am taking over here the example just like as y is equal to 1 plus x over 1 minus x. Okay, and we want to find the dy by dx. Okay, so if we want to find the dy by dx, okay, here around find dy by dx. Okay, for this let 1 plus x over 1 minus x is equal to u. If we take it u, then it means that y is equal to the above equations. This will be equal to u square root. Okay, and when we take the derivative of this, then it will be just like as dy by du, dy by du, it will be equal to 1 over 2 and u power minus 1 by 2. Okay, 1 by 2 minus 1 is equal to minus 1 by 2, and this can be written as 1 over 2 and u square root. So this will be equal to 1 over 2 and 1 over 2 and the value of u is 1 plus x 1 minus x, and when we will put this value in the denominator, so it will be written just like as 1 minus x. This 1 minus x will be written on the numerator and 1 plus x will be written because u square root is in the denominator, and when we put this value over here, then we can write it just like as 1 minus x and 1 plus x. Okay, is this is dy by du. Now we apply the chain rule. The chain rule will be applied just like as it is dy by dx. Okay, this will be equal to dy by du and du by dx. This is the chain rule. And now putting the value over here, you can find from here. This implies that if you find the du over dx, okay, so you will apply over here the quotient rule. Here you will, because it is 1 plus x and 1 minus x, and when you apply the quotient rule over here to find the derivative of u, this will be equal to, this is your assignment, I'm not writing it, it will be 2 over 1 minus x square, 1 minus x square. Okay, so now putting the value over here, so what is dy by du? You know, dy by du is equal to this one, which is 1 over 2 and 1 minus x over 1 plus x. Okay, and what is du over dx? It is 2 over 1 minus x square. Okay, so this is 2 over 1 minus x square. Okay, 2 over 1 minus, it is actually, yes, and this is actually 1 minus x square. 1 minus 2 over 1 minus x square. And after simplifying, we will get just like as 1 over 1 plus x square root, and here you can write it is yes, this will be 1 minus x and 3 by 2. Okay, so you will just not much more work, you will just simplify it. Okay, so this is the way how to apply the product rule, how to apply the chain rule. Okay, there is one more example, and that example is very related to just like you can say again power rule. Okay, yes, the example is, I would like to discuss this example because this example is much important, and this example applied. Okay, it is let y is equal to ax. This is not about quotient rule, and yes, you can also apply quotient rule over here. Yes, we will apply the quotient rule over here. Y is equal to ax plus b raised to the power n, and we want to find what we want to find. We want to find dy by dx. If you want to find dy by dx, then it means that this can be written as let u is equal to, okay, here let u is equal to ax plus b, then it means that this can be written as y is equal to u raised to the power n. And when we find the yes, dy by dx, okay, or since it is u, we will differentiate with respect to u, then it will be dy by du, and this will be equal to n u raised to the power n minus 1. Okay, and in the similar way, if I take the derivative of this u with respect to x, it will be du over dx. So the derivative of u is equal to ax plus b. The derivative of ax is a, and the derivative of b is 0, of course. Okay, so now we apply the chain rule. The chain rule is just like as dy by dx which is equal to dy by du and du over dx. Okay, now apply over here dy by du. So dy by du, we know that it is equal to n and u n minus 1. In a similar way, du over dx, it is equal to a. So yes, this is a. We can write it n a, and we know that the value of u is equal to ax plus b. So put over here ax plus b n minus 1. Okay, so this is the way how to apply the chain rule. Okay, so after that we have studied about chain rule, and now we want to study a little bit more about derivatives, because our target is to understand the basic things. When we will start the astronomy course, the mathematics that will be used in astronomy, then these things which are the basics, you should know about these things. And if you will not get mastery on these things, then it is very hard for you to understand about the mathematics that is used in astronomy. So derivatives of trigonometric and inverse trigonometric functions. Here I will not taking any kind of example. I am just reviewing the some concept, just like if we say that derivative of sine, if I take y is equal to sine x, then you know that the derivative of dy by dx, the derivative of sine, this is trigonometric function sin x cos x tan x, okay, and this will be cos x, okay, this will be cos x. In the similar way, if we take y is equal to cos x, and the derivative of cos x is, it will be just like as dy by dx, and the derivative of cos x is, it is minus sin x, okay, yes. And after that, tan x, if we take y is equal to tan x, okay, then it will be dy by dx which is equal to secant square x, okay. So we can prove these formulas by the first principle. The first principle is a principal technique that is being used to find the derivatives, okay. But here, since our target is to understand the astronomy, therefore we are not proving this formula. We are just reviewing these formulas, and after reviewing these formulas, we will apply in astronomy the mathematics that will be used in the astronomy. In the similar way, if I write the derivative of cot x, this, you know, the, yes, d by dx of cot x, the cot is the inverse of tan, therefore cot x is equal to minus cosecant square x, and d by dx cot x secant x, this will be equal to secant x and tan x. In the similar way, the derivative of cosecant x, d by dx of cosecant x, this will be minus cosecant x minus cosecant x and cot x, okay. So there are some trigonometric formulas just like that should be discussed over here, okay. The trigonometric formulas are, these are just like the derivative of sine inverse x, d by dx of sine inverse x, which is equal to 1 over 1 minus x square, okay. And this derivative exists only when this condition is satisfied. The value of x naught should be less than, the absolute value of x should be less than 1, okay. And in the similar way, the derivative of d by dx of cos inverse x, and this will be equal to minus 1 over 1 minus x square, and of course here the condition of absolute value of x must be applied, okay. and d by dx of tan inverse x, tan inverse x, it will be equal to 1 over 1 plus. So these are the formula that you should know, and these formula maybe will apply in the mathematics that will be used in astronomy. Okay, and that mathematics which is used in astronomy is a high level mathematics, and over there we will deal with high level of derivatives and higher level of integrations, means differential and integral calculus, not basics but high level of differential and integral calculus will be used in astronomy. Okay, the mathematics that will be used in astronomy. So not we will not only learn about mathematics that is used in astronomy, I will also explain the facts that the mathematics which is being used in astronomy, what is the relation of that mathematics with the astronomy, just like planets, stars, meteors, asteroids, all other objects that we see on the sky. So what is the relation of those mathematics with these objects? Okay, we will discuss over here, but to discuss these things we first need to understand about basic things. So I am giving you 1 hour lecture of differential calculus, and I will give you 1 hour lecture of integral calculus, and after that we will start the mathematics that will be used in astronomy. Okay, so now these are the formulas, and we know that the d by dx tan inverse x is actually cot inverse x, the derivative of cot inverse x, it will be minus 1 over 1 plus x square. Okay, and the yes, cosecant d by dx of secant inverse x, d by dx of secant, which is the opposite of cos, secant inverse x, its formula is equal to 1 over x and x square minus 1. So wherever x square minus 1 or x minus 1, over there this condition will be multiplied, x mod is greater than 1. Okay, and now the derivative of cosecant, d by dx of cosecant inverse x, and this is equal to minus 1 over x into x square minus 1, x square minus 1, and as I have already explained that the condition of x mod must be greater than 1. Okay, so our formulas are not finished yet. There are some other formulas, and these were the formulas about trigonometry, and after trigonometry we will discuss some other formula, just like the formula that are related to log. Just like if I write y is equal to log of x with base a, then its formula dy by dx in this case is dy by dx, and this will be equal to 1 over x. Yes, it will be equal to 1 over x and natural log of a. Okay, 1 over x and natural log of a, this formula. Okay, and after that yes, there will be some other formulas, just like if we will take y is equal to a raised to the power x, okay, where a is any real positive, okay. And in this case, if we take the derivative dy by dx, then our formula will be just like as it will be equal to a raised to the power x, a raised to the power x, and just like it is natural log of a. So I would like to give the example of this, just like as if y is equal to 2 raised to power x, then what is dy by dx? The dy by dx will be dy by dx is as it will be 2 raised to the power x and natural log of 2, okay. So this is okay. So this is the mathematics that is used in astronomy, okay. So you can say that we are studying the undergraduate level mathematics that is used in astronomy, okay. Yes, now I think lot of formulas that we have seen over here, but here now we are discussing about the some hyperbolic functions, sine hyperbolic, cos hyperbolic, tan hyperbolic, just like as these functions. Of course these functions are also trigonometric functions, but we will discuss these functions. Now there are some other formulas, just like sine hyperbolic x, okay, sine hyperbolic x, this is equal to e raised to the power x minus e raised to the power minus x divided by 2. Similarly, cos hyperbolic x is equal to e raised to the power x plus e raised to the power minus x divided by tan hyperbolic x. Okay, in the similar way you can write tan hyperbolic x, which is equal to e raised to the power x minus e raised to the power minus x divided by e raised to the power x plus e raised to the power minus x, okay. So the formulas for the hyperbolic functions, the derivative formula d by dx of tan hyperbolic x, tan hyperbolic x, it will be equal to secant hyperbolic square x, secant hyperbolic square x, and d by dx of cot hyperbolic x, cot hyperbolic x, and this formula is minus cosecant hyperbolic square x, okay. In the similar way, d by dx of secant hyperbolic x, secant hyperbolic x, this formula will be equal to minus secant hyperbolic x, secant hyperbolic x, and tan hyperbolic x, okay. And d by dx of cosecant hyperbolic x, the formula will be minus cosecant hyperbolic x and cot hyperbolic x. D by dx of sine hyperbolic x will be d by dx of d by dx of sine hyperbolic x, it will be equal to cos hyperbolic x, and d by dx of cos hyperbolic x, it will be equal to sine hyperbolic x. So these are all the formulas which are being used in differential calculus, and this type of calculus will be used in astronomy. Hope you have understand about this lecture, and I will meet you in the next lecture again in the integral calculus. Thank you very much.